So in our previous example about deck production, we figured out that the Z statistic was 1.547, right? Which was less than the critical value. And so as a result of this, H naught was not rejected. So the way that we find a p-value from a Z statistic is we round this to the 100th place. And then we're going to wait for our laptop to actually make stuff. 2 decimal place, 1.55. And then we're going to use our Z table to find the probability of finding a Z value of 1.55 or more. And since this is a two-tailed test, so let's go ahead and draw this out. So as always, we've got a z-scale here, so down the middle is going to be 0. It's important for us to keep in mind, is it a one-tailed test or a two-tailed test, right? And so our null hypothesis had a equal sign in it, and a alternative had a not equal sign, so it's going to be a two-tailed test. So finding the probability of a Z value of 1.55 or more, right? This is our Z axis, our Z scale over here. And so we have to, for a two-tiered test, we have to go to negative 1.55, and then we have to go to positive 1.55. So we literally have to go inside of the table, right? Because if you remember, the table has, you know, different numbers that are related to the first two digits and the third digit or whatever, right? And so then we had all these numbers inside of here. So you actually have to go in here and find where 1.55 is. And it's where it's the 0.0606. So this ends up being 0.0606 here. And since this is a two-tailed test, we're going to take each one of these values and we're going to add them together. So the first step is we round it. The second step is we go inside of the Z table to find the probability of finding a Z value of 1.55 or more. Take a look at our null and alternative hypothesis, figure out if it's two-tailed test or one-tailed. If it's two-tailed, we're going to take whatever that probability is, and we're going to multiply it by 2. This is going to equal 0.12. So this p-value is the probability that the test statistic is as extreme as the value computed when the null hypothesis is true. So our particular example, we were trying to figure out if the mean value is greater than 203.5 while the population mean is 200. And so we find this is our p-value. And then we compare the p-value to the level of significance. And so we were told that the level of significance is 99%. So 99% is going to correlate with an alpha of 0.01. And so since we have a p-value that is greater than the alpha, right, 0.1212 is greater than 0.01, we are going to fail to reject HO. So again, same conclusion that we had at the top, right? Where we talked about our Z statistic being less than the critical value, so we can't reject the null hypothesis. The p-value being greater than the alpha, the level of significance, is going to also result in our H naught not being rejected.